Hey guys, welcome to the 8th lesson on fundamentals of C# programming. Today we're going to be talking about inheritance. We're going to talk about what inheritance is, why we use it, and how we use it. Alright, so to get started, inheritance is the idea of creating specific classes that are directly based off of more general classes. When we create a class that inherits from another class, the class directly inherits all the traits and characteristics of the class that it is inheriting from. Um, the class that is being inherited from is called the base class, and the class that is doing the inheriting is the derived class. When we use inheritance, it normally creates a kind of tree diagram in how the classes are organized, because the base classes are the more general classes, and as we create classes that are derived from the base classes, they become more specific because they inherit all the traits of the base class, but then add on their own traits and their own functionality in the new existing in the new classes that we are creating. So the easiest way I think to understand inheritance is to definitely see it by example. So we're going to start off by doing a simple example just showing the basic concepts of inheritance, and then we'll dive deeper into more complex topics and then continue on from there. So to get started, I'm going to build a simple class called animal, and animal is going to have some basic, I'm going to make it have like two properties, a constructor probably, and I'll give it a method that it can display one of the properties or something like that. So just to get started, we're going to go to our Solution Explorer, and we're going to right click on our project and add a new class. Actually, let me move it over here so everyone can see. Uh, this is annoying. Alright, so we right click on our project, we go to add new item, or we can go to class. I'll just hit new item. When the new item screen comes up, we go to class, and then we can type in our class name right here. In this case, I'm going to call my class animal, and hit enter, and then we're good to go. So let me dock this over here, and then let's get started. Okay, so the first thing I'm going to do is create two properties that will hold some information about our animal. I want to make a property for a name, so our animal has a name, and I'm going to have a property for age so we can see how old this particular animal is. Now, I'm going to make these properties, and I introduced you to properties in the last lesson with dealing with classes, but I didn't show you a shortcut way for creating properties. In the last lesson, I showed you that we could create properties, and the job of a property was to help monitor and control the access to our private data in our class. And I'm going to show you a shortcut for creating a property if the control to our private variable is very basic, and when we're not making any changes to the property that are really dramatic, then we can use these shorthands for creating properties. The shorthand is called an auto implemented property, and the auto implemented property doesn't actually contain any private data. It automatically creates the private data for us behind the scenes, so we don't have to explicitly write the private data. So the syntax for it is very simple. We're just going to say public, then our data type for our property. In this case, we're going to make a property called name. So our data type will be string. And then we'll say name. And then we're just going to go in our curly braces, get semicolon, set semicolon. And this is the shorthand because if we were doing normal properties, we would have to create a private data and then create our public property that will help monitor that private data. But the auto implemented property just says that it creates the private data behind the scenes, and then this allows us to do very basic control. If we're going to need more complex control of our private data, then we would use a full property rather than an auto-implemented property like this. However, with the auto-implemented property, we can still provide some kind of control to our private data. So we could, for instance, say if we made this a private set by going like this, we could control who can actually set the data of the data of the property. By doing private set, the only the class itself can modify the contents of this property. Any class that tries to modify this from the outside would not be able to change it because it's set to private set. So we still do have some control with properties, but just it's not as powerful as building a full blown property. I'll go ahead and make another property for age. I'll go public int age get set, and that will be our second property. I'll also create a function for our class that we'll just display our age to the console. So we'll build a simple function. We'll say public void display age, no parameters, and inside our block we'll just go console dot write line. We'll use some placeholders and we'll say placeholder is placeholder years old, and we'll plug in the name and the age of our animal. So it will look like name is however years old, and that's what we'll display to the console. So the first time around in this basic intro to inheritance, I'm not gonna create a constructor just yet because I haven't really taught you much of what happens when you use some inheritance. So I'm gonna first do without creating a constructor, and then I'll go in and add a constructor later. So now that we have our animal class, and I said that this will be our base class, and the job of the base class is, I mean, it's not actually the job of the base class, but the base class is normally more general than any classes that are going to derive from this base class. And in this example, our base class is going to be an animal. So the next class we're going to create is going to be more specific, but it's going to be an animal. So we're going to create a dog. So let's go to our Solution Explorer once again. And let's go ahead and add another class, add class, and we're going to create a class called dog this time. And obviously a dog is a type of animal, but it's just a more specific type of animal. So a dog should definitely inherit all the traits of what an animal class has, but it should definitely include some more things that are unique to a dog itself, that's making it more specific. So the syntax for creating a class that derives from another class is to use a colon next to the class name. So we'll say dog colon, and then we're saying derive. That pretty much means derives from animal. So by doing this, just to start out with, our dog now inherits all the traits of our animal. And before I go on and add more specific things to the dog, I just want to show you this quickly in our program. So the first thing I want to do is create an animal class right here. So when I say animal A1 equals new animal, and I want to give my animal an age for 5, and I want to give my animal a name, and I'll say, I don't know, Fred. So my animal has an age and a name now. And as you can see, my animal can also use the display age function right here. Now, first, I'm going to go ahead and go back to my dog class, and I'm going to remove the inheritance from my dog, and I'm going to create a dog object now. So I'll go dog d1 equals new dog. If I want to go d1, you'll see that the IntelliSense isn't showing me anything because right now dog1 or dog, it's just an empty class and has no code whatsoever. However, I'm going to delete this, and I'm going to go back to my dog, and I'm going to inherit from animal once again. And now when we go back to my program and I go d1 dot, you'll see that my dog now inherits all the traits and properties and methods from the base class. So we can see I have age, display age, and name. So I'll go ahead and set an age for my dog. I'll say my dog is 2 years old. And my dog's name, I'll say, is Molly. So now I have my dog, and go ahead and go d1 dot display age, and this will work perfectly fine. And when I run the program, we see the output over here. It says Fred is 5 years old, and Molly is 2 years old. So we were able to fully use the entire animal class without actually having to recode any of it inside our dog class. And our dog class is completely using um, all of the stuff that our animal class has. Now, using this kind of inheritance built a relationship in our classes, and this is considered an is-a relationship. This is considered an is-a relationship because a dog is an animal. It's completely an animal. A dog contains and has everything that an animal has. So in essence, a dog is completely an animal plus more. So that's why this is considered an is a relationship. Um, anywhere that would require an animal, let's say within a function or anywhere that requires an animal, you could pass in a dog because a dog is a type of animal. And I'll go ahead and show you something very simple like that. So I'll go ahead and make a very simple method real quick. So private static void take in an animal, and I'll say take in animal A right there. And I'm not going to build any code. I just want to show you that if we had a method right here that took in an animal, for instance, we could call that and say take in animal and pass in D1 because D1 is a dog and a dog is a animal. So anywhere we see animal, we could pass in a dog. Now this is just the basics of inheritance, so I'm not going to talk much about that just quite yet. But from how we have it set up right now, if we were to pass in our dog to this function that requires an animal, it would get passed in, and on the other side, when it got into the function, the dog would be stored into a variable of type animal. So in essence, the animal, when we access the dog in this function itself, we would only be able to use the animal side of the dog. We wouldn't be able to access anything that is specific to the dog unless we used some casting, and we're not going to get into that just quite yet. Um, all right, so let's go ahead and remove this. So I'll get into that later in the lesson probably. If not, we'll get into maybe some other lesson. But this is just the intro to inheritance. So now that we have our animal or our dog is directly inheriting from our animal base class. I'm going to go ahead and give some more traits to the dog to make it more specific, to show that a dog is not just an animal, a dog is a dog. So I'm only going to add a couple things. The first thing I'm going to add to my dog is I want to make another property called color. I'm going to say my dog can have a color to it. So I'll go private. I'll make it a string in this case. Color gets set. So I have a property for color now. And then I'm also going to build a function called bark. Dogs can bark, so I'll give the ability for my dog to bark. And we're to stimulate a bark, we're just going to write to the console, and I'm going to say blah 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 is barking. And I want to show you something cool here. So this placeholder, I'm going to put in the name of this dog. And because my dog is directly inheriting from the animal, I have access to all the things inside the animal. And I'm going to talk about another access modifier that's going to be introduced with inheritance, but anything that's public inside the animal, I can directly access. So inside my animal, I had a public property called name. So because dog is an animal, I have a name. This dog has a name. So I can just plug in right here name, and this will get it from the animal portion of it because it's directly related. So by doing this, I can plug in my name and my dog, and if I make my dog bark, it will say the name of the dog is barking. So if I go back to my program class and instead of, I'm going to comment out this animal, I don't need it right now. But with my dog, I'm going to, instead of doing display age, I'm just going to go ahead and do bark now. And I run the code, and you can see it says Molly is barking. It's pulling Molly from the animal class because a dog is an animal. I'm also going to show you, if I uncomment this real fast and I try to go A1, you can see that we don't see the bark function at all, and that's because my dog is inheriting all the traits from animal, but an animal is not a dog. A dog is an animal. It doesn't go both ways. So an animal is not a dog, so an animal can't bark. But a dog is an animal, and I just added more functionality on top of that base class animal, so I can go D1, And we can see that bark there because it's a dog can bark. We added more specific functionality to a dog. Okay, so the next thing I'm going to start talking about is this is the basics of inheritance, like the really, really basics of inheritance. A couple of things to note before I go on. The first thing to note is classes can derive from many classes. So, for example, my animal class is the base class of dog, and dog derives from animal. I could make another class that's maybe more specific, maybe puppy, and I could make puppy derive from dog, and then dog still derives from animal. So we can create a chain hierarchy of inheritance or of derived classes, and that can go on forever. You can have as many as derived classes as you want up the chains. You can have a puppy derives from a dog, derives from an animal, derives from etc. 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 So that's the first thing to note. The second thing to note is that in C sharp, um, you only can have single inheritance. And in other programming languages, that does change. And I will be doing lessons for other programming languages like Java and C++ soon. And in a language like C++, you could have multi-base class inheritance, and that means that a class can inherit from many base classes. However, in C sharp, that does not hold true. In C sharp, you only can inherit from one base class. So that means if I had a puppy class, I couldn't make puppy derived from dog and derived from animal or other classes. You only can have um, only one class can derive from another class. You can't have multi inheritance. However, we do in C Sharp have other ways to maybe sort of get around that, and I might show you that in this lesson. If not, maybe I'll show it in another lesson, and that's called or that's using interfaces. And maybe I'll start talking about interfaces a little bit, but it doesn't give us the full power of multi inheritance, but it certainly does allow us to do some other things with inheritance. Um, so yeah, so the next thing we're going to talk about is using constructors with inheritance. Now, using constructor with inheritance definitely gets a little tricky because, as you can see in this class right here with my dog, I have access to my name. I have access to my class an animal name property, and that means that somewhere in behind the scenes, the animal class was actually completely built because the property for name, the only reason why I can access that is because the animal itself was made also. So when you derive from classes and you create derived classes, so like dog, when I create an instance of dog, I'm actually creating an instance of all the classes that dog derives from to make sure that everything is okay, because the dog class might use some things in its base class, like animal in this case, and in order for that to happen, the animal class has to be made and its constructor has to be called to make sure the animal is prepared to be used in other classes. Um, so using constructors does get a little tricky, and I'm gonna hopefully show you how it's not that hard if you can see the basics of it. I know for a fact when I started learning programming, stuff like this always made me really confused because it's hard to visualize it in books and reading it, and I don't know, it's just hard. So I'm gonna hopefully try to clear that up because I know I struggled with it, so I can hopefully point out the points where I struggled and hopefully clear them up for you. So inside of the animal class, I'm gonna build a constructor for my animal. My animal constructor is gonna take in two parameters, and it's gonna take in a name and an age, so I can just help build the animal class. So to build a constructor, it's the public keyword followed by the name of the class. So in this case, animal, and then the parameters. So I'm gonna pass in a string name and an int age to my thing, into my constructor, and then my constructor is simply just gonna pass those values to my properties. So I'll say I can either go. I forget if I actually showed you this keyword in the last lesson. I think I did. I don't remember. If not, I guess I just won't use it right now. I could just go name uppercase n for my property name equals lowercase name, and age equals age. So I'm simply just assigning the value of what's passed into my constructor to the properties of my class. So I'm gonna go back and I'm gonna delete this code, and I'm gonna go ahead and create a new animal. I'm gonna say animal a1 equals new animal, but this time I need to pass in some data for my animal. I'm going to pass in its name here, Molly, and its age 5 right there. So right now, when I create my class, it's fully built. My properties have the values that were passed in at this point, and now I can go ahead and just call display age right here, and everything will work fine. So a1.display name, display age, and bam, oops, we have an error. Oh, okay. I'll talk about this in a second. Let me go ahead and just delete this. Let me go ahead and run this again, and we'll oops, name doesn't exist. Okay, that's embarrassing. Let me just comment this out, and let's try this one more time. Alright, so we can see that our class is built with our constructor. I just wanted to show you that everything's functioning with our constructor. We passed in our data to our constructor, and we called our display age function, and everything's working fine, showing that our constructor did indeed assign the values to our properties. So let's go ahead and go undo what I just did here. So you might have noticed when I ran it the last time, it threw an error. And the reason why it's throwing an error is because the dog itself doesn't have it, or if we were to create a dog, we aren't supplying the needs of the animal class, because the animal class now, in order to create an animal, it has a constructor, and an only way to create an animal is to use the constructor that's supplied. And by default, it doesn't know if we were to create instances of dog. We need to build the animal class first, and at this point, we don't have any information being passed into the dog to build it. So if I go ahead and do dog d1 equals new dog like this, and go d1 dot, I don't know, display age, I'm gonna get some errors still once again, and you can see it says lesson 8 dot animal. So my animal class does not contain a constructor that takes 0 arguments. So the reason why it's saying that is because when we create a dog class, it's trying to create an animal from that with no arguments, with 0 arguments. And that's why it's saying animal doesn't have a class with 0 arguments. If I went ahead and made another constructor for my animal class with 0 arguments, then we would have no problem. But because when we create a dog, which in essence is an animal, when we create that dog, it's creating an animal class also. So we need to fulfill the requirements of the animal as well. So in order to do that, we need to create a constructor for our dog, that when we create a dog, we can pass in some things for our dog, and then that will pass it to our animal class. And we also can then add in something else. So because our dog class has a color, we'll make our constructor also have a color involved. So first thing we need to do is create a constructor for our dog. So we'll say public dog. The first thing we need in our dog is we need a name for our dog. That will be for our animal portion. So we'll say string name, then we'll say int age, and then we'll say string color. So those are all things we need. Now, the first thing I want to do, this is going to error, the first thing I want to do is just set my color equal to color. Now, I don't have to go name equals name or age equals age, because I'm going to pass that into the base class constructor. And then that will do it itself, because that constructor already has that programmed. Now, to call the base class constructor, it's just a basic syntax. I'm gonna go here and hit enter, and it will bring me to this line. I'm gonna do a colon, type in base, and when I put in my parentheses, you can see this is gonna call the base class constructor, and it's showing you what I need. So I need a name, so I'll just pass in name, comma, age, just like that, very simple. So now I have my dog class with its dog constructor. When my dog is created, it comes in, it first creates the animal, then it comes back, then it assigns the color, and then it continues on. And this may be confusing to you, but the important thing to note here is that when you create a class that is derived from another class, it has to create and fully instantiate the base class first before we can go on to create the dog class, because the dog class may need things in the base class. So this is what it's doing. So I'm going to go ahead and go into my program. I'm going to delete this code and I want to create a new dog object. Dog D1 equals new dog. I want to pass in a string called Molly, an age 5, and a color, I'll say brown. I'm going to put a breakpoint here, so I want to show you what is actually going on and show you what the compiler is doing when we step through it. So I'm going to hit start. Here's my program start. I'm going to throw it over here. We don't need that right now. And I'm going to step into it by hitting F11 or this button right here. So we step into and we get into the constructor of the dog class, which is perfectly what we're expecting. We'll see that the name Molly is being passed in, age is passed in 5, and color is brown right here. When I step into this, we'll see that we'll step into the animal class. It's going into the animal class because it has to build the animal class first. And because we supplied the dog with a name and an age, and then we passed that using the base keyword, we see that Molly and 5 were passed into the animal class constructor as well. So when I step into that, we assign the name, the age of this animal class, and when I'm done, we come back to the dog class. So now we have our fully animal class designed and built, and now we can proceed with creating our dog class. So when I step in, it then does the things that are specific to the dog itself, and that is the color. So then I assign the color, I continue, and then we're good to go. Our dog class is built, which consists of also building an animal class. So that's really the basics of constructors when we use derived classes. I'm sure the syntax, if you're new to this, is definitely confusing you. So this is my dog's constructor right here. This is a new portion of the constructor, which is simply just passing in what's passed to the dog and forwarding that to the animal constructor to help build the animal class. Because we know that to build an animal, we need well, we know that a dog is an animal. So to build a dog, we have to also build an animal. And we need the same information in our dog to build that animal. So our dog needs a name and an age. So we're just forwarding that to the animal class itself, so the animal class can build its class first. So yeah, this is the basics with the constructors. Really, I mean, this will come in time, being able to program something like this. But the most important thing to get out of this is just, I can't emphasize this enough, you just have to remember and understand that when you create an instance of a class that has a base class or is derived from another class, it has to build and instantiate the base class first before it goes ahead and creates the more derived class. So that's just the most important thing to grab out of this. Okay, so the next thing we're going to talk about, we're slowly getting more and more complex with the features of inheritance. So the next thing we're going to talk about is start talking about the basic idea behind a concept called polymorphism. And I'm only going to go into it a little bit, but polymorphism is basically the idea that classes or derived classes, and as we get to more specific classes, can behave. They can behave in a different way, or a way that is more unique, or it somehow changes from the base class. A polymorphic thing is something that can, I don't know, adapt to its surroundings, and it pretty much changes in order to help the itself, and it can help itself better. So how we use it is, if we have a derived class that uses some polymorphic features, we can take features from its base class and modify it and morph it a little bit to better suit the class itself. So I'll show you how we could do that a little bit. So to start out with, to use some polymorphic features, we have to start out by I'm going to introduce you to two new keywords. So I'm going to go into my animal class, and I'm going to mark something as a polymorphic thing, something that can be changed in more derived classes to help better suit the class. So to do that, we're going to have to use the virtual keyword. So by marking something virtual, we're saying that this virtual thing is prone to change. It's prone to being modified or completely rewritten and to perform a different action that helps better suit the more derived class. So I want to put the virtual keyword in this function right here. So it's going to say public virtual void display age. And just by adding the virtual keyword, this is fine. It can keep the same behavior right here. But by marking it virtual, I'm saying that any class that derives from animal has the opportunity to rewrite this function to help better suit itself. So inside my dog, this, by the way, this is just an example purpose. It's not going to make that much sense, but I'm just trying to show you the basic idea. So inside my dog class, I'm going to go ahead and I'm going to rewrite the functionality of that virtual or polymorphic function. So to do that, we just need to override that function. And that's the next keyword. That's the new keyword I'm going to introduce to you. It's the override keyword. So to do this, I'm going to go public override. When I hit space, it's going to show me all the things that I can override. Now, you may be wondering, why is it saying I can override a function called equals, get hash code, and toString? And I'm not going to go into that right now, but the reason why I can see these things is because all classes implicitly inherit from a class called object. And I'm not going to talk about that much right now, but just note that by default, this class, animal class, and all classes are inheriting from a class called object, which obviously has functions and things that of its own, and in this case, it has a couple functions that are marked virtual that we could override. But we're not worried about that right now. What we're worried about right now is a function that we see right here called display age, and we can see that because we marked animal as virtual, we can go ahead and override its functionality inside in my new class. So if I could go ahead and hit enter on this, it kind of builds the class for me, and it does a couple things. The first thing it does is it sets it up. It sets up the override function for us as if it's assuming that we want to maintain all the functionality of the class itself, or of the function itself, and build onto it, which is perfectly fine. So I'm going to do two examples. I'm going to first show you if we just do the basic syntax for creating an override function. It creates this function called right here that says base.displayAge, and all this is doing is saying the first thing it's going to do is call the base function displayAge. So it will call this function first and then continue on doing anything that you add that is more specific. So I'm going to go ahead and just go console.writeLine, just adding more specific code and saying I'm just going to make it in all caps dog, just to show you that we did some more specific things. I don't want you to get confused with this function right there, so I'm just going to move it down there. So I overrided the display age function. I still maintained all the code inside that function, but I just added in saying that this is coming from the dog class. So to do this, I'm going to first create an animal. I'm going to say animal A equals new animal, string name Molly, and Molly is 5 years old. I'm going to go A.display age. I'll run that code, and we see Molly is 5 years old. I'm going to go ahead now and make another class. This one's going to be dog. I'll say dog D equals new dog. New dog. And my dog is going to be called Fred. He'll be 2 and he is brown. I'm going to go D.displayAge. Now note, even if I didn't override display age, I would still have complete access to this function because my dog inherits all the traits of the animal class. By overriding it, I'm just being able to modify it and make it more useful for the dog itself. So when I do it this time, we'll see that it calls, I mean, let me uncomment, I mean, let me comment this so it doesn't confuse you. So let me run it again. So we can see when I call display age here, it first does Fred is 2 years old, which that is the full functionality of the animal's display age. And that's happening because I maintain this base.displayAge function call. But the next thing you see is the console.out for the dog keyword or the dog word, and that's because I modify the display age function to add more specific functionality for my dog. Because my dog is calling this function, this overridden display age, which just has, which is just calling its base class, its base class's display age function. So I'm gonna go ahead and throw throw a breakpoint for you guys to see what happens when I step through this. So it's calling the function. I'm gonna step into it. We can see it's entering the overridden display age function. As it hits the base display age function, I step into that. We come into the virtual function, which is right here, the base one, and it's doing its output right there. So if I go ahead and hit the next button, you can see I have no output right now. When I hit it, go back to it, it says Fred is 2 years old. So this output right here is coming completely off from the base class animal. When I come back, then it goes console.writeLine dog, and we're inside the dog class right here. So there you have it. So that's the basic with overriding virtual functions. However, I want to show you that you don't have to always maintain you don't always have to maintain the code from the base class. So we don't have to call the base display name or display age. If we wanted to build a class that derives from a base class and overrided a base class function, we don't have to keep the functionality of the function. So if I wanted to completely rewrite and make a completely modified function, I can go ahead and just delete that line of code, and now everything's still the same. But if I run my program, instead of making the base call, it just does the basic dog console.out, which is right here. So yeah, we're just not calling the base class method anymore, but we're still overriding the functionality of it. So to the class caller itself, when it goes d dot, it can't actually see the display age for the animal because we're overriding that. The only display age it sees is the one that we're overriding, and that's the one that's this one right here. If I were to delete this, however, and go back to this and do a d dot, you can see the d dot display age. It's now using its base class's virtual function. As you can see, it says animals dot display age now. So this is once again a confusing topic, and it's probably a little hard to understand. But if you watch this and try it yourself, maybe building your own classes, you'll slowly understand what I'm doing here. So yeah, once again, I made a virtual function that simply allows this function to be overridden and allows it to be allows the code to be modified to help the derived class to become more specific and to help the class more. So my dog class overrides that display age function and then provides its own functionality to it. And if you want, you can maintain the base functionality of that function and add on to it, or you can completely delete that and rewrite your own functionality to whatever you want. Okay, so before I move on, I just want to go back to something that I talked about a little bit in the beginning of the lesson, and that is the idea that a derived class is a base class, or a derived class is said to follow the relationship or use the is a relationship. And I want to just go back into it. I started going over a little bit by showing you that function call before, but I just want to continue with that a tiny bit more. So because a dog derives from an animal in this specific example, a dog is a animal. So anywhere that an animal is required or anywhere an animal class is used, a dog can be used in that place because a dog is a type of animal. It has that is a relationship. So I'm gonna build a function that will just display the name of the animal that's passed in. So I'm gonna go with private static void display name of the animal that's passed in, so animal A. And then this is just going to go console.writeLine A dot name right there. So it is a very simple function. However, I just want to show you, first I'm going to create an animal class. So animal A1 equals new animal, plugins name, Molly, and 5. And then I'm going to go display name, and I'm going to pass in A1, which is all good because it wants an animal, so I'm passing in an animal. So I'll go ahead and run this, and you'll see when I run it, it does indeed say Molly. So everything's good with that. But the next thing I want to show you is if I create a dog called D1 equals new dog, and I say Fred is 2 years old, and Fred is always brown. If I go display name D1, everything still works. And if I go ahead and run this, we'll see Molly and Fred is still displayed. And now this is what is really cool about inheritance, is because a dog is a relationship. So a dog is an animal. So anywhere you see animal, literally anywhere that an animal is, if I created an array of animals, I could put in some of the elements as dogs. Obviously, they'll be held in reference or in variables of animals, which maybe I'll talk about soon. But nonetheless, you could still hold it in that array. But in this case, this function requires an animal. It says I have to have an animal or it will not work. And because a dog is an animal, everything works. If I were to delete the inheritance right here and then try this again, it would throw an error because it requires an animal. Now, once again, because this is an introduction course to inheritance, I'm not going to go into that much. But depending on what you guys want, if you guys give me feedback to see what you want to see more, what topics you want to go into, and things like that, if this is something you want to see, I will go into it more. But I just want to show you the basics with this a little bit more. You may be wondering if this class says I require an animal, and a dog is an animal. Well, if I pass in a dog to this animal function, the dog reference, when it gets passed in, that reference is being held in a variable of type animal. So that means I can only access the things of that reference through an animal variable. So if I go a dot, I can only see things of an animal, although I could hypothetically be passing in a dog. So I kind of lose the things in that dog. Now, that's not entirely true. I can retrieve the contents of that information, but by default, I only can access the things of that variable because D1 is getting passed in, which is a reference to a dog object. Because I'm passing that through a which it gets passed into here, which is going to be held into a variable of type animal, I can only access the animal stuff of the dog. Now, I'm going to show you a way that we can access the other things, but it does get a little tricky. So I'm going to start off by just deleting the animal to help protect us to start off. So I showed you this, I think, in lesson 1 when we started talking about casting a little bit. And there are a couple ways to do this. I'm going to show you it with casting the first time. And what I'm going to do is, because I know I'm the programmer, because I know I'm passing in a dog object to this function, I know it is indeed a dog. It's a dog stuck inside a variable of type animal. But because I know it's a dog, I can retrieve that dog information even though it's being held inside of an animal. So right now, if I run it again, just to refresh your memory, it is indeed pulling Fred. But notice that dog has a color attached to it. It has a color that is unique only to a dog. So if I go a dot, I don't see that color because, like I said, it's being held in an animal reference. So in order for me to access that color of that dog, I need to convert it or cast it to a dog. And that's what I'm simply going to do. So I'm going to create a new variable, say dog, dog, my dog, let's say, equals a, but I'm going to get an error here because an animal is not a dog. But I'm going to cast it. I'm going to say dog. I'm going to force it into a dog. By forcing it into a dog, I'm converting my reference. I'm converting my variable that's holding a reference to a dog into a physical dog object. So now this is being held into a reference of a dog. So now I can access all the things that are inside the dog. So if I go my dog dot, we can see now we have the age, color, and name. So if I want to display the color, I can go ahead and run this, and I do indeed see that brown. That brown, I pulled it out of the variable, even though it's hidden on the surface because on the surface it's an animal. So I need to convert it to its dog, and then I can access its properties. Now, there are problems with this. Using this approach, there are problems. And if you can see those problems, that's really good. That means you have a good eye for programming. But if you can't see those problems, it's no big deal. The problem arises when if I left it just like this, I would run into lots of problems. For instance, if I delete this right here and create an animal object, animal A equals blah 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 blah. I say Molly 5, and I go display name A. I pass in my animal. Everything's good at a design time, but once it runs, it's gonna have a problem. So if I run this, you'll see, bam, boom, everything crashes. I get an exception, invalid cast exception. And the reason why I'm getting this invalid cast exception is because an animal is not a dog. I'm passing in an animal to this, and I'm forcing an animal into this dog variable. Well, it's impossible. I haven't created a dog yet. No dog was created. Only an animal was created. So this is definitely one problem. Now, using this approach, I could make a solution, and I could have a solution for this and to fix this problem, to fix this crashing problem, which this invalid cast exception. I could fix this, leaving it this way. Now, I don't. I'm going to show you a different way of doing this, but in the next lesson, which is most likely going to be a lesson on exception handling, I'll show you maybe a way I can fix this. But the way I can fix this, if you maybe know exceptions right now, is I could catch any exceptions for invalid exception or invalid cast exceptions. And if that happens, I can just throw an error saying this object is not a dog or blah blah blah, and I would just stop it before it tries to access before it tries to access the color of the thing. And the reason why it's getting an error, or another reason, is because if you think about it logically, an animal is not a dog, so there's no way an animal has a color. So that's why this is breaking. Now, because of this, I have to introduce you to a couple more keywords. The first keyword is the is keyword. Now, the is keyword allows us to check before we go ahead and actually do the converting or the casting to see if indeed the class that's being passed into the function is, or I mean the class that's being converted actually is the type that it needs to be. So for instance, or for example, to do this, I'm going to use the is keyword. I'm going to go if A, which is the animal or whatever is being passed in, is a dog, then I'm going to do something. In this case, if it is, I'm going to go ahead and display its color. Actually, hold on. I'll show you why this is erroring. Before I do that, I'm going to say else. If it's not a dog, I'm just going to go ahead and just go console.writeLine and just display a dot name. So if it's a dog, I'll display its color. If it's not a dog, I'm just going to display its name. And the reason why it's getting an error right here is because I don't have a my dog yet. So I have to create that my dog. And to do that, I'm going to use another keyword, the as keyword. And the as keyword is pretty much just going to help me convert anything I want. So the first thing I'm going to do is, if I go if A is a dog, I'm going to say let's treat A as a dog then. So I'm going to create a reference to dog saying my dog. And I'm going to say treat A as a dog. So by saying treat A as a dog, I'm perfectly protecting myself in this example. Because if I'm going if A is a dog, then take A, which is a dog maybe, in a reference or in the variable, and convert that into a variable reference holding a actual dog. So if that is the case, I convert it into a dog, and then I display its color. So let's go ahead and run this program. You see the first time it works fine. It goes ahead and says Molly because it knows Molly is not a dog. Molly is just an animal. And it's just an animal because I created it just as an animal. If I were to create a dog now, say dog D equals new dog, I'll convert Molly into a dog. And then I go display name D. Now when I run it, we'll see its color because it's saying A is a dog. It is a dog because we created it as a dog and we passed it in as a dog. So that's why it's falling into this portion of the if statement, because it is indeed it is a dog. Now by doing this, by using this is operator or is keyword, it protects us from anything. Because we're not actually doing the converting until we are sure that it is a dog. So it protects us from any exceptions being thrown. However, we could, if we wanted to, we don't have to use the is keyword, but we still always have to do checking. We could say hypothetically, dog, my dog equals dog, equals A as a dog, but what if it isn't a dog? Then we get a problem. So I'll show you what happens. I'm going to go console.writeLine. I'm going to go mydog.color. I'm going to create an animal up here. So I just displayed my animal into this. I'm going to run this and see what happens. Oh no, it's crashed again. However, this time I'm getting a null reference exception. So that's a side effect of using the as operator. If you use the as operator and it tries to attempt to convert whatever you're trying to convert, if it actually can't convert it, it will just set it to null. So what it's doing, it's setting my dog to null. So I could simply just say if my dog, if I do not my dog, actually I don't know what I'm doing. If my dog is not equal to null, then we'll display its color. Else, just go ahead and just do console.writeLine a.name. So this is doing the same exact thing. Before we just use the is operator or the is keyword to help protect us and make it more neat. But if we wanted to, like I said, we can just convert it right in the beginning, and then we'll just do a check to see if it's set equal to null or not. If it's not null, then we know it was a dog. If it is null, then we know it was just an animal. So we can go ahead and we can see now it properly displays Molly. Now, so that's the basics actually, just with understanding the basic concept behind the is a relationship. like I said, if you guys want to see more with things like this, if you want me to dive deeper into topics that I say that I'm just trimming the surface or skimming the surface, I could dive deeper down, but I need your guys' feedback. If you really want to see this, then by all means, I will dive deeper into whatever topics you want. But my goal of these lessons is just to help people understand the basics of programming, more specifically the basics of programming in C Sharp. But I'm also teaching you or trying to teach the basic ideas behind object-oriented programming as well. So if you want to see more specific things like this, I will by all means do it. Okay, because this is almost an hour long already, I didn't realize, I'm only going to show one more thing in this lesson. The last thing I want to show is once again, another keyword. I feel like I've shown you guys a lot of keywords in this lesson. I think this is going to be the fifth keyword, or new keyword that you're going to be introduced to. And this is the abstract keyword. And pretty much the basic idea behind the abstract keyword is fairly simple. It's actually just an idea. So sometimes when you're building hierarchies with inheritance, if you're building base classes, derived classes, and so on, there are going to be times that the base class is just so general that there's never going to be really a purpose of ever creating an instance of the base class, right? There'll be times that the base class is only actually there to be used as the base class of derived classes, never actually to be instantiated on its own and to be its own standalone class. Now, when you come across those times, you're going to use the abstract keyword, and the abstract keyword is just there to help you for a simple reason. So I'll show you what I mean by that. So if I were to make an animal a base class that will never be used to be instantiated, just animal will only be used to help create other more specific classes, like my dog, I can go ahead and mark it abstract. So when I mark it abstract, that first is making it, okay, now animal cannot be instantiated anymore. It only can be used as the base class for other classes. The next thing in this is, however, I can now mark functions as abstract. And by making functions abstract, I'm simply saying that I'm not going to supply any functionality or any definition to that function inside of this abstract class. Rather, I'm going to leave it completely up to the derived class to provide its own functionality and to override it. So to do that, I'm just going to replace the virtual in this case with abstract, and I'm going to make display age abstract. Now, in this case, as you can see, it's complete. Oh, actually, hold on. I need to delete this and perform a semicolon. An abstract function has no method body. It simply just says that you must implement. If you derive from this base abstract class, any abstract function you must override. So it's just saying that, well, this doesn't exist anymore. It's just saying I have to override display age, which I am doing already. So if I didn't override it, let me just get this away. If I try to run this, I get some errors. And it's saying that I don't implement the abstract function called display age. So it's just saying that any abstract function you mark abstract inside an abstract class must be overridden by this base class, because the purpose of an abstract class is to simply be used as the building block for other classes. It's never to be used as a class itself. So if you mark an abstract function inside an abstract class, the reason why there's no function definition is because it can never be called by itself. It only can be called through another base class. So it only makes sense to override it and perform or implement its own behavior for that more specific class. So in this case, the dog. So I'll just go public override display age. And okay, so because this is a pretty long lesson, I'm not going to. I was gonna maybe go into interfaces, but I'm not going to in this lesson. and I don't have plans to do it for next lesson. Maybe after that. Next lesson I want to go into exception handling and things like that. But if you want to see interfaces, you just do a quick Google search and maybe think interfaces are kind of interesting. I'll definitely go into doing interfaces. But that's all I'm going to do with inheritance right now. I showed you a lot with inheritance, and it's kind of confusing. So I definitely recommend, if you want to fully understand inheritance, the best thing to do is to go ahead, maybe follow the same example that I did, or possibly build your own example, maybe by using other things, other classes. Try to build your own hierarchies um, in your own code. Um, yeah, so I hope you enjoyed this lesson. And like I said, the next lesson is going to be on exception handling. So thanks for watching.